Assalamualaikum warahmatullahi wabarakatuh. Today we will present our mathematical model entitled Intravenous Feeding of Glucose. Background of study. Glucose is the main source of energy for the cells in our body. Intravenous feeding is used when the digestive tract cannot absorb nutrients and requires a tube which must be inserted into a large vein. In the case of glucose, it is essential to know the concentration of glucose that is added intravenously to the bloodstream. A mathematical model is a process of mimicking reality by using the language of mathematics. As this model is related to the rate of change over time, it is suitable to implement the differential equation in our calculation. Our objectives of study are first to obtain the concentration of glucose in the bloodstream over time. Second is to solve the problem using the method of first-order ordinary differential equations with initial condition. And third is to understand better the usage of differential equation in solving real-life problems. Next, I will pass to my group member, Farah.
Okay, so next is mathematical formulation. We will use the application of the IVP that consists of first order ODE, and then we will use the method of linear equation. Linear equation is a type of first order ODE that depends on the independent variable. From the application of first order ODE, the mathematical model for our intravenous feeding of glucose is dc over dt equals to r minus kc, where r equals to 0.75, k is 0.05 with initial condition when t equals to 0, c equals to 0. So these are the parameters where c is the concentration of glucose solution in bloodstream, r is amount of glucose solution administered intravenously to the bloodstream, k is constant, t is time, dc over dt is the rate of change of the concentration of glucose solution in bloodstream. So next, I will pass to Nurainaa Zafirah.
Okay, as for manual solution, we use method of linear equation to solve the first order ODE like Farah has said before. By calculating the integrating factor, we will get exponent 0.05t. Next, from 1, multiply both sides by the integrating factor and solve the equation. We will get the general solution as shown in the slide. Next, we need to substitute the initial condition to solve for the IVP, and we will get d1 equal to negative 15 and substitute back into the general solution. Therefore, we will get the solution as shown. Hence, the general solution that we have calculated helps in determining the value of glucose that needs to be added intravenously to the bloodstream for our mathematical modeling of intravenous feeding of glucose. Next, for computer-aided solution and graphical analysis, first we import library SymPy as sim and initiate t and c to sim.symbol and sim.function so that it will become a symbol and a function respectively. This is our first order ODE, and by using sim.dsolve, we will get our general solution like this. Next, to find the constant, use sim.solve and substitute t equal to 0 into the function, and we will get c1 equal to negative 15. Substitute the constant into the solution, we will get the general solution as shown. For the graph, import the library numpy and matplotlib.pyplot, and from scipy.integrate, import ODE in or ordinary differential equation integration. Next, we define our model with c and t as the input or argument, return dc dt, and declare the initial condition and the time points. The model initial conditions and time points are defined as inputs to ODE in to numerically calculate the CT. Next, plot the graph using plt.plot with title of concentration of glucose versus time and set label CT as y-axis and time as x-axis. Use plt.show to display the graph. So from the plotted graph, it concludes that the concentration of glucose in the bloodstream increases proportionally to time. So I will pass to Siti Sarah.
We will use Theorem 1 and definition of continuity to prove the existence and uniqueness of solution. As you can see in this calculation, we use the definition of continuity to prove that both functions and its derivative df over dc and dc over dt are continuous in any rectangle containing the point 0, 0. So the hypotheses of Theorem 1 are satisfied. It then follows from the theorem that the IVP has a unique solution in any interval above x equal to 0 of the form 0 minus delta, 0 plus delta, where delta is some positive number. Next, I will pass to my group member Raudhah to conclude.
Bismillahirrahmanirrahim. For conclusion and improvement, inshallah, in Surah Yunus verse 57, Allah has reminded us to take care of our health as believers. We have two flaws for this project, which are our study constant and also glycosuria patients. Our study constant is because human body can actually maintain a constant glucose concentration despite the presence of external energy. Meanwhile, glycosuria patients, also known for those who have diabetes, leads to inaccuracy in the calculation because the kidney may not take enough blood sugar out of the urine before it spreads throughout the body. Our suggestion to improve would be to focus more on glucose homeostasis, which eventually helps us to identify abnormality oscillation patterns of the blood glucose and also insulin. Based on what? Based on the prediction of blood glucose changes under insulin deficiency. I think that's all from us, Doctor. Thank you.